cosmic void birth silhouette, TOI 561b's jagged crust glows. We drift closer, witnessing the planet's dark, charcoal-colored terrain, scarred by eons of intense geological activity and extreme heat. We descend rapidly toward the surface. Black basaltic plains are fractured by rivers of molten magma, glowing with intense, primordial heat. A low-altitude flight captures the shimmering heat distortion above the lava, where volcanic haze clings to the planet's scarred, rocky face. The camera pulls back, revealing the planet's terrifying proximity to its host star, which dominates the sky like a massive, blazing furnace. A year on this world passes in a blink. One full orbit completes in less than 11 Earth hours, defining a life of extreme heat. We transition to a wide view of the ancient Milky Way, where the TOI 561 system resides as a relic of the galaxy's early history. The camera travels through the cosmic expanse, moving toward the TOI 561 system, revealing the tiny, rocky world orbiting its star. A top-down orbital view shows the planet racing around its star, a stark contrast to the slow, steady pace of our own Earth. We return to the surface, gliding over vast, dark volcanic islands surrounded by seas of glowing, silicate-rich molten rock. The camera crosses the Terminator line, moving from the blinding, sun-scorched day side into the dark, cooling, yet still volcanic night side. Atmospheric currents swirl in the darkness, carrying heat away from the day side, a hint that this world is more than just bare rock. We observe the night side, where the rocky landscape remains visible under the faint, eerie glow of distant stars and internal volcanic heat. We leave the planet behind, drifting into the cold silence of space to find the James Webb Space Telescope, our eye on the cosmos. Webb stares toward the TOI 561 system, capturing infrared light to decode the secrets hidden within the planet's intense thermal signature. A scientific visualization shows the planet passing behind its star, a secondary eclipse that reveals the heat radiating from its surface. Elegant thermal data curves appear, illustrating the infrared light fluctuations as the planet disappears and reappears behind the star. We compare two models. A bare rock would be scorching, but the data suggests an atmosphere is redistributing that immense stellar energy. The atmospheric model shows a more uniform heat distribution, contrasting sharply with the extreme temperature spikes of a bare rock scenario. Back on the surface, gases rise from the molten terrain, drifting upward through the hot, hazy atmosphere toward the stars above. The camera tilts upward, following the flow of volcanic outgassing as it transitions from the molten surface into the thin, shimmering haze. A cross-section view reveals the planet's structure, a hot, rocky interior feeding volcanic outgassing that sustains the mysterious atmosphere. Deep within the planet, molten reservoirs churn, acting as a constant engine that replenishes the gases lost to the star's radiation. While we cannot confirm the exact chemical makeup, models suggest potential compounds like water vapor or carbon dioxide may be present. We return to an orbital view, where the subtle, glowing atmospheric rim encircles the dark, rocky world against the backdrop of space. The host star looms large, its intense radiation hammering the upper atmosphere, threatening to strip it away into the vacuum. We zoom into the upper atmosphere, visualizing the interaction between stellar wind and the gases being pushed into the surrounding space. Beneath the surface, the molten reservoir acts as a constant engine, replenishing the gases lost to the star's relentless stellar wind. This is the central mystery. How can such a substantial atmosphere persist on an ancient, irradiated world? The answer remains elusive. We place Earth and TOI 561b side by side. One is a temperate blue oasis, the other is a dark, molten, and hostile super-Earth. The scale comparison highlights the difference between our temperate home and this extreme, volcanic world orbiting so close to its star. The comparison serves as a reminder. Rocky worlds come in many forms, and not all are destined to be like our own home. We begin our final sequence, rising from the magma-scarred surface, slowly revealing the curvature of the planet against the deep black. The camera continues to pull away, showing the entire planet beside its nearby star, emphasizing the scale of this intense environment. The system becomes a tiny point of light as we pull back further, eventually revealing the vast, beautiful, and mysterious Milky Way. We finish with a final hero shot of TOI 561b, dark and rocky with its molten day side, slowly fading into the darkness of space.